Okay, we're going to look at product and quotient laws now for logarithms. Just a quick reminder of what we knew from before, or what we know from before. If you're looking at something like 3 squared times 3 to the exponent 5, if we were to solve that, there is a nice little rule for it. Where it comes from, of course, is just what happens if we expand this. I get 3 times 3 for here, times 3 times 3 times 3. 5 more from here. And of course, what that ends up being is 7 3's all multiplied out, or 3 to the exponent 7, which means that our rule for our product rule when we're dealing with exponents is if the base is the same, we can multiply we can add the exponents to get a simplified original version. Similarly, we have a rule for division. This is essentially x times x 6 times on top. Wow, dragging my pen. Sorry there, guys. 1, 2, 3, 4, 5, 6. And of course, same idea on the bottom. There are 4 of them. And so those cancel, 4 on them. X divided by x is 1, x divided by x is 1. And at the end of it, we're left with x times x on top, or x squared, which reminds us that, struggling today. We could have simply subtracted the exponents. And that's our quotient rule when we're dealing with exponents. And as we know, the log is the exponent, so obviously these are tied together momentarily. So I just wrote it right here. Just a quick summary of what we saw above. 3 to the x times 3 to the y would therefore be just 3 to the x plus y. I'm going to use that on the next page. I should have probably hidden this a little bit. So I'm going to say let m be 3 to the x and be 3 to the y. So nothing there is too fancy, just representing my original values with other variables. That means that m times n would have to be the same as 3 to the x times 3 to the n, because of course the original values were the same. We've discussed before, we can simplify this to this. And now if I rewrite this as a log, this is my exponent, this part here. So where I would have had 3 to the whatever number before, or just 3 to the x before, I now have x plus y. So that's the answer to the logarithm, log base 3 of my other term, which is mn. So hopefully nothing there is too fancy. You won't have to go through what I'm going through right now. I'm just kind of showing you the rule that we'll end up using, but this is kind of going to be a proof that it is legit. So we already said we're going to let m be this and n be this from before. Well, based on what we know of logarithms, that means that this term could be rewritten as x equals log base 3 of m. Y could be rewritten as log base 3 of n. That's, again, by definition what the logarithm is. The log is the exponent, so this thing is exactly the same as the exponent. Same idea there. Since we saw from before that x plus y, or using the x plus y equal to log 3 mn from before, we've already shown that that is true given m this and n that. We could therefore conclude, I got my sinces and therefores mixed up here. Not sure why that happened. So since x plus y is this, we can therefore conclude that the x value being log to the base 3 of m, and the y value plus the y value, which is log to the base 3 of n, must also be equal to this, just by straight substitution, right? X is the same as this, and so we replace the x with that. Y is the same as this, and so we replace y with that. And so this becomes now a rule. In the same way that when we multiplied two exponents before, kind of going back to this, when we multiplied two exponents with the same base before, and we were able to add the exponents, the powers themselves. Now if we're multiplying two terms as an exponent, we can add them together as well. So this can be split up into two pieces. And again, remember, these are exponents. So I'm multiplying my exponents here, I'm adding my exponents here for simplification. So just a quick review then. These are the various rules. The product rule is the one we just saw. So if I'm multiplying two terms in a logarithm, it can be expanded to be the other way around with an addition. Or if I'm adding two terms, certainly I can use this the other way as well. If I have log to the base b of x plus log to the base b of y, I can simplify that to log of b x times y. Similarly, there is a quotient rule. If I'm dividing here, subtracting here, just like, again, on that very first page, I'm dividing, I subtract my exponents. I'm dividing, I subtract my exponents. I keep stressing the log is the exponent. And then I just kind of included this because it was right there as well. This was the power rule from last day. When I have log of an exponential expression, the exponent itself can be multiplied by the rest. Again, same sort of idea. This is an exponent, and so technically I have an exponent here to another exponent. When I have an exponent to an exponent, I multiply.